So what we learned from a previous video is that the probability distribution table contains the same exact information as a histogram. So we could get our information either from the probability distribution table or from the histogram. And we're going to use histograms in a few of our next examples. But before we do that, we want to learn how express the events in the forms of inequality. So let's take a look at that. It says, let y be the number of heads out of 3 tosses of a fair coin. Express the following events using inequality. So first of all, our variable y can take on values, number of heads out of 3 tosses, so 0, 1, 2, or 3. And then we have certain probabilities of that. Let's express the events. So 3 tosses of a coin result in 2 heads. So that would be y equals 2. 3 tosses of a coin result in less than 2 heads. So that would be y is less than 2. 3 tosses of a coin result in at most 2 heads. At most 2 heads means it could be 2 or less. So that would be y is less or equal to 2. 3 tosses of a coin result in no more than 2 heads. So 2 is also acceptable, and less than 2 is also acceptable, but not no more. Okay, so it's y is less or equal to 2. So see how these events are identical as expressed as inequalities, but they're worded differently. So learn these wordings because you're going to see them in the problems. The next one is 3 tosses of a coin result in at least 1, but no more than 2. So at least 1 means y is greater or equal to 1. At least 1 or more, but at the same time is no more than 2. So 2 is acceptable, so it could be less or equal to 2. Okay, so but the thing is, this is not the only way to express that event. At least 1, but no more than 2. We could also say it's between 0, more than 0, at least 1 is more than 0, right? And less than 3. That also says the same thing. Or we could say greater or equal to 1, so that's at least 1, and less than 3. Or we could say greater than 0, but less or equal to 2. So all 4 of these inequalities, they basically express the same idea that 3 tosses of a coin result in at least 1, but no more than 2. So that means 1 or 2. This is 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 1 or 2 as well. So here's the continuation of what we just talked about. So once we expressed our events in the form of inequality or equality, and then if we put that in parentheses and put it next to P, capital P, that will represent the probability of that event happening. All right, so let's practice of actually finding those probabilities. So here we have a probability table and a probability histogram. And we need to find the probability of x is less than 2 and the probability of x is less or equal to 2. So first, let's actually do it using both table and the histogram and see what the connection is. Okay, so less than 2 means includes 0 and it includes 1. So that would be represented by these 2 bars. And so the height, okay, as we already mentioned, the width of each bar is 1, and the height here we have 0.08 and 0.12. So the probability that the x is less than 2 is going to be 0.08 plus 0.12, so 0.20. Now, where can we get that information from the table as well? Yeah, that's included right here, 0 or 1. These are our values for the variable, and these are corresponding probabilities. So just add them up. Now, for the next probability, x is less or equal to 2. Now we are including 2. So it's this bar right here. So we're including it. And the area of that bar is 0.16. So we're adding it on top of this, the previous sum. So it's going to be 0.08 plus 0.12 plus 0.16. So that results in 0.36. So we could find it using the histogram. Notice the area, or we could find it using the table, either or. And this is a very important connection to draw between the histograms and the tables. So the probability is the same as the area. And here's some probability rules that we already talked about, but we're going to just reiterate them. So the total probability is 1. So if we add all of the bars and all of these probabilities, we're going to get a 1 here. And also that the probability of x, that x is less or equal to a, is this equals to the probability that x is less than a plus the probability that x equals to a, as demonstrated here. So in order to find the probability that x is less or equal to 2, we first figure out the probability of x is less than 2 and then added the probability of x equals to 2. So in the next question, we are asked to find the probability that y is greater than 0 but less or equal to 2. And we already figured this bit. So we're going to focus on this one. So 0 is not included there. So we're looking for the probability of 1 or 2. 2 is included. So only these 2 bars. Okay, so that in the table, that's going to be right here. So the probability is 0.12 and 0.16. So we're gonna get 0.28. Okay, and this is actually tied in with the probability rules that we learned earlier, right? So this is going to be the probability of y equals 1 or y equals 2. So how do we figure out the probability of or? That's the probability of 1 plus the probability of the other. Okay, so addition rule, and that's what we apply here. And as we mentioned earlier, all of these expressions, they're basically covering the same two probabilities, probabilities of 1 and the probability of 2. So it could be written in any one of those 4 ways. All right, so let's talk about the probability that y is less than 2. So less than 2 could be 0 or 1 versus the probability of y is greater or equal to 2. So 2 is included here. And remember, we said that this bar, it's not including the right end, it's not including 2. But the next one right after this is including 2. And since we have greater, then everything that's on the right side of 2 is included as well. So basically, these two expressions, they cover the entire histogram. So what we can conclude from here is the probability of y is less than 2 plus the probability of y being greater or equal to 2 will cover the entire space, and it's going to be equal to 1. But let's go ahead and figure out each one separately, and that's going to be it's going to be 0.08 plus 0.12. We already did that. And then for greater or equal to 2, that's going to be 0.16, 0.28, and 0.36. So that will add up to 0.8. So when we figured out this probability is 0.20 and this probability is 0.8, and yes, it adds up to 1 as we suspected. All right, let's take a look at the next example, and here we're invited to find the probability that y is less or equal to 1. So that will include these two probabilities, and that is 0.08 plus 0.12, and then greater than 1 and less or equal to 3. So that will, so this first one is right here. And the next one will include 2 and 3. So we're going to have 0.16 and 0.28, which is 0.44. And then the probability that y is less than 3. It actually is going to include all of these together, right? So we're going to have here if we call this event A and this event B, so it's going to be A and B together. It's going to be 0.20 plus 0.44, 0.64. Let's take it one step further. So if we call this event D, then this bit of it is gonna be not D, or D with a bar, complement of D. So this is how it all works, and we have our probability rules right here. So everything that we did just now is summarized in these probability rules. So rule number 1, the total probability is 1. If we add all them up, they should add up to 1. The inequality, probability that x is less or equal to a is the probability of x is less than a plus the probability that x is equals to a. The complementary rule, the probability that x is less than a and greater or equal than a should add up to 1. It's actually a derivative of rule number 1. And of course, like if we subtract this on both sides, we're going to get this rule. And the subdivision rule, the probability that x is less than a plus the probability that x is between a and b, including the endpoints, is going to result in the probability that x of x is less or equal to b. And again, if we subtract this on both sides, we're going to come up with this rule. So those are discrete probability rules. And next, we're going to talk about mean variance and standard deviation of a probability distribution.